All right, well, thank you, Sydney. Thank you all for being here. I normally don't drink coffee, and today I've had 3. So I'm hoping that I don't break into high-frequency samba up here, because it's just about to go jittery like this. OK, so we had submitted an abstract about hot technology topics. In the course of really crafting this presentation, it ended up looking more like an information age technologies and how these are panning out. So stay with me on this as we kind of step all the way back, and then we step all the way back down again. There is a lot that is happening in HPC that, in my opinion and in our opinion, and maybe I should just say it up front, that part of what we do at OrionX is to track technologies. The technologies that we track specifically are data center, AI, and IoT. There are other relevant technologies that show up that are interesting, that we have an aptitude for. Some of these technologies are not entirely completely defined, so we are doing our contribution to understanding and touching the whole elephant, so to say. So you will see some of that here. Is this working? It's not working. So we're just going to do this. That should work. No, that's not working either. OK. No, OK, it's happening now. OK, so let's step back and talk about the information age. So we are at the dawn of information age. Now, we live in an environment and an industry where the word era is used quite easily, right? And then you look at the Jurassic period, and it's just a period. It's not even an age, let alone like an era. So information age is a pretty big deal. It's like a really long period of time. So information age, by definition, has to do with information. A big part of it is information extraction. When you extract information content from anything, we call that digitization. It's about information processing. IT systems are there to help us process information. When it comes to information interpretation, that's when HPC comes in. So when we look back, we think HPC is the engine of information age. It's a big deal. It isn't just another topic. It is absolutely the only way to make sense of the information age and the challenges that it is representing, that is bringing to us. And we're going to probe those a little bit as we go down each of these 3 areas and talk a little bit about what's going on in each one. So look at digitization. There were things that we called revolutions. There was an agricultural revolution. Agricultural revolution ended the Stone Age and the Bronze Age and the Iron Age and that fun period of time when life was just seriously difficult. Then we went to Industrial Revolution, and then now we are in the information revolutions. Revolutions, by definition, are messy things. Lots of bad things happen in revolutions. Sometimes it's sort of good, sometimes it's bad. So the economy, the agricultural revolution led to the agricultural economy. The Industrial Revolution led to manufacturing economy, but it didn't mean we left agriculture behind. It sort of made this mechanized agriculture. And information economy is now, information revolution is leading to the service economy, but we're not leaving manufacturing and agriculture behind. We call it digital manufacturing and digital farming. And those are really pretty big, important, hot areas. But each of these revolutions also caused a whole bunch of problems. The agricultural economy, I'm sure, caused a lot of problems. The ones that really kind of still lingers to some extent is the cultural, social, economical problems that it caused. Likewise, the Industrial Revolution caused a bunch of social, economical problems. It caused a problem with automation that was focused on automating actions, automating muscle. It obviously caused climate problem that we're still going to deal with, and it's leftover problem in a big way. It caused a problem with jobs because it fundamentally changed the nature of the jobs from kind of an apprenticeship to what we know and love as jobs today. And it changed money. It kind of required modern finance to make it all happen, a notion of a corporation, all of that. Information revolution will change all of that again, and hopefully will help us solve some of the leftover problems from the industrial age. Social economical model, automation, this time automation of decisions, not action. Awareness, connectivity, everybody's a lot more aware. Globalization just falls right out of that. Mistrust. There's this notion of digital mistrust right now that is very, very palpable to all of us. And all of this is happening with seriously accelerated change. All of this is happening in like 75 years instead of 250 years like the last time, or like 3,000 years the time before that. And as biological entities, we're not quite ready to absorb that kind of a change that fast. So that was digitization. Now let's go to IT systems. IT systems, we've kind of gone from 3 waves, and we are now in the beginning of the 3rd wave. We went from terminal mainframe to client server, now to mobile cloud. Every time we go through one of these waves, it's not like the last one disappears. There's still a very nice $10, $20 billion a year market in mainframes. It's just not where the action is. Client server will probably carry on being a $50 to $100 billion market, but it's not going to be where the action is. The mobile cloud is going to be in the trillions of dollars. Each time, it's going to be like a factor of 10 to 100 or whatever. And a lot of stuff changes. Fundamentally, one of the things that change is that in the terminal mainframe, you sold systems to an IT shop that provided applications to a user. With client server, you sold chips to system vendors that sold to IT shops that provided applications to users. With the mobile cloud, you're selling chips to systems who sell it to cloud providers who now provide services to the end users. So the value chain changes every time you go through this. And with it, everything else changes. OK. It was working. OK, maybe not working. Oh, OK. All right, we figured this out. OK, so HPC. So that was, remember, the 3 times. The left-hand side was digitization, then was IT systems. Now we're talking about HPC. So HPC really is the engine of information age. Why? Because when you digitize, you get data. When you get a lot of data, you have to make sense of it. Like I like to say, if your spreadsheet has 200 rows, it's a spreadsheet. If it has 2 billion rows, it's HPC. There is no other way to make sense of it. So in order to make sense of data, you need IT, and you need an understanding of STEM, science, technology, engineering, math. That is exactly what HPC is, and that really is what drives it. Now, you look at the history of HPC, it really started with history of science. You have a new idea, and you experiment. Thank you, Galileo. We figured it out. We have a formula for that now, right? And if your theory was valid, the experiments would kind of reinforce and would answer the questions that the theory caused. With simulation, we now have the triangle, and then we renamed new idea to a theory. So now you have theory, experiment, simulation. Some of you who have worked with me have seen this slide for like 15 years, but it's still a valid slide. So simulation leads to a new way. New way wants to be automated. Automation leads to instrumentation. You gather new data. New data wants to be visualized and interpreted. It leads right back into simulation. You have communication in the middle. And this becomes the virtuous circle of HPC. And knowing math, knowing science, knowing data is really what is needed to do anything in the information age. All applications will be big data applications. All applications will be AI applications. AI was languishing for decades before HPC really rescued it and boosted it and made it interesting again. So now with that, we go to the hot topics on each of these areas. So stay with me again for that a little bit. Let's start with IoT, Internet of Things. When everything has an IP address or everything is somehow connected, all these devices, you put that in the context of digital mistrust. You obviously need to make sure that these things behave well. AI is coming to help. Big data is coming to help. Generally, the model that we are proposing and kind of observing is this, is that you've got at the edge, which kind of has its own networking protocol, and you've got devices, and the devices have sensors on them. At the next level up, you kind of have the local layer, and you can have a router, and you can have local treatment as a gateway. Now, you could have multiples of these gateways, depending on just how expansive the IoT network becomes. At some point, you want to move all that data into a data lake and apply some intelligence to it. So those become the 3 layers with the understanding that the one in the middle is level 1.x. So you can have multiple layers in the middle, kind of recursively. Now, an event occurs at the lower level. That turns into a trigger. The intelligence turns it into an insight. You've got business objectives. You've got policies that says how you have to deal with the insight. The policies turn into a command. The command turns into a control. And this kind of becomes another virtuous circle. So this is how one way to look at IoT that kind of makes it make sense in a relatively crude, simple way, but valid enough. All right. I mentioned Bitcoin in the abstract, so I got to mention Bitcoin. So one of the things that technology does is changes the meaning of money. And indeed, the world is in search of digital currency or cryptocurrency. Bitcoin is something that we all have heard about. But if you look at the, they're like something on the order of 28 digital currencies whose market cap is bigger than $10 million. Now, for Bitcoin itself is $17 billion. It's starting to have more of a market cap than some of the major currencies out there. So what is Bitcoin? Bitcoin really comes with this other technology called blockchain. I'm sure you all have heard of it, so this hopefully is not too much of a repeat. So Bitcoin is essentially digitized gold, complete with the mining analogy. You have to mine it, and there is limited supply, and at some point you're going to run out. Come 2140-ish, they expect, there will be no more Bitcoins. We have extracted all that the world has to offer. Blockchain is a technology that essentially manages a distributed ledger. So there is no sovereign force. There is no bank that makes sure transactions are consistent and coherent. The coherency in a distributed way requires that you have a way to avoid cheaters. How do you avoid cheaters? By making cheating computationally very expensive. So this is kind of the flip side of HPC to some extent. But authenticity is assured by the computational challenge that is to make sure transactions are consistent. It is gaining an acceptance. The increasing use cases are out there. But there is an occasional legal challenge that if you look at the price curve, it kind of drops occasionally. That's because somebody lobbed the legal challenge to it, usually a government or something. OK, so now we go to the next one, which is AI. AI really is HPAI. It's high-performance artificial intelligence. Low-performance artificial intelligence didn't really work. It was expert systems and fuzzy logic, and that did not really pan out. When AI started being effective is when HPC resources and HPC expertise got applied to it. So the essence of AI is that intelligence is now computable. Intelligence is computable is a really big deal. And that has huge ramifications, of course, as we all know. This is our simple way of looking at it. You've got artificial intelligence at the top. On the left-hand side, you've got simulation and HPC. On the right-hand side, you've got automation and IoT. I personally think that all of that is essentially HPC and what HPC wants to be going forward. In the middle, you've got cloud. And then you've got numerical processing, logical processing, and you've got big data that feeds all of it. All right. So the next one is what's happening to apps. And what the heck is happening to apps? There was a time when apps were hello world, and the way we learned back in school in the beginning, you just wrote a little routine, and it was the entire app. Over time, the logic of the app became more and more and more distributed, until today, where we call it microservices. And you've got serverless and Amazon's Lambda and things like that, where things come online, do something, and then they disappear. The job control part was just a command, and that became a job control, and then it became scripts, and then it became more complex scripts, and now you have workload scripts and network scripts and ticketing and all that. And then the data traffic. When you have just one blob of an app, there is no data traffic. It's all inside the app. You make it 2 pieces, now you make it 3, you make it 4, you make it 5. By the time you get to microservices, the data traffic within the app requires networking. Networking becomes a big deal in the app because the guy who wrote the code that checks whether or not your credit card is valid has no idea whether one request is going to come at it or 5 million requests are going to come at it. If it's 5 million, you need a lot of networking coming in, which is why the fabric is now so important. Now, the fabric has always been important in HPC. it's now becoming even more important for all of the applications. So what do you get on the right-hand side? You get elasticity, microservices, serverless stuff. Now, in HPC, sometimes we've already done these years and years ago. Sometimes we haven't, and we're going to, because the transactional kind of computing is not traditionally what we do. It's more of like a job kind of work that we do. And the whole transactional data center versus job data center is another distinction that we need to be conscious of as a community. On the control part, it has to do with policy, service level agreements, programmability, and on the traffic side, it has to do with topology, network services, of which security really is one. All right, so what are the opportunities for differentiation? We've gone from few servers to many servers, few small files to many big files, wired clients to mobile clients, client server to mobile cloud. What does that mean for system architecture? At the system architecture, it means data center as a system. People like Google, people like these extreme guys are now looking at the entire data center as a single circuit board, meta circuit board. And all the boxes on the raised floor are just chips. And in fact, if you put the aerial photographs of them side by side, they look quite identical. In-memory computing, leveraging supercomputing for commercial applications, power efficiency, those are some of the things in the architecture. For the next big thing is correctness. Consistency, object storage, asset compliance, now going to CAP. These are the things that are really important, especially with flash memory coming in, that really changes the nature of persistence. Mobile clients lead to service level agreements, and that's kind of service software-defined networking, application delivery controllers, IoT, those are all relevant to that. And then on automation, you've got security, again, elasticity, and DevOps, which is really the implementation of applications in a commercial production kind of an environment. So some of the things that we see here. Now I'm going to end with this data center predictions. We have an article that just got published in the Register, and these are the 10 predictions for data centers. Some of them were kind of out on a limb a little bit, but we'll see. We named the article a rear view mirror of the 2017 data center. So number one, data center optimization is here. Data centers have a lot of moving parts. The last time anything had that many moving parts was the entire company. When the company had a lot of moving parts, it led to applications like SAP and Oracle apps and PeopleSoft and Siebel and Salesforce.com. It's a multi-billion-dollar area that created to make sense and ability to control the enterprise. The data center is now becoming something like that. So data center infrastructure management is a category that is coming in a big way. We think Azure will grow faster than AWS. Both of them will grow quite handily and nicely and comfortably, and life will be happy, because if you're touching cloud, you're on the right side of history, and you will benefit from that. But we think that Microsoft has some advantages in terms of traditional applications that it can pull into its cloud relatively simply. The next one is what we call the Great Wall of Persistent Memory. The Great Wall of Persistent Memory becomes a thing because it is actually quite useful for application developers. Somewhere that they can just deposit, and it is fast, and it's big, and it's persistent. We think system vendors will increasingly announce racks rather than servers. We already see Intel going with the rack scale architecture more and more towards just building the entire rack before you kind of build the entire data center. So the geographic focus, if you will, of what is being designed is changing. Server revenue growth will be lower than GDP. We saw in last quarter of 2016, server revenues dip for the first time in some time. And this time it wasn't quite because of virtualization. It was probably because of the pressure that is on servers from multiple directions. There's more explanation of that in the article. Open power, we think, will emerge as the viable alternative to x86. If you've noticed, there are like multiple camps being formed in the industry. Obviously, Intel now has its own chip and its own GPU and its own fabric and its own this, that, and the other. So that's kind of an example of I'm going to do everything in-house, and if you go with me, it'll be highly integrated and life is good. On the other side, you've got the Open Power Foundation, which is kind of an integrated best of breed. All the players in there, from NVIDIA to Mellanox to other members, are really the best of breed in their market segments. So we think that has a lot of legs, and it will, in fact, be an important alternative. We put one that my car will break down on 101. And the joke there was that the navigation system was in cahoots with the stereo system, and they hijacked the car. So this is an example of saying that IoT security is a big deal. And we are going to have significant issues with IoT security. The last time this happened was this denial of service attack that commandeered something like 25,000 cameras, surveillance cameras. And because they're all connected and there's an IP address, each of them became a client that was hitting at this name server out on the East Coast. There are more chips than Vegas, riskier too. This is about the whole let 1,000 flowers bloom. There are all sorts of, for the first time in decades, there's an opportunity to do a new chip. The binary contract that really moved Intel forward is cracking with new applications, with open source software, with cloud computing. They have the wherewithal to really buy enough to make it viable and build the software infrastructure. Current applications, modern applications, have no idea what CPU they run on. They are way on top of a very tall stack. So if you can build a stack underneath them, they'll just run, right? And open source allows you to do that. There's more explanation there as well, but some really, really interesting, innovative chips are coming from. The flip side, and this is an advantage to Intel, is that ARM server market will continue to be anemic. Lots of noise to be made, lots of very, very good projects, but not translating to real dollars. The problem is that ARM can't differentiate against x86, just like Atom couldn't differentiate against ARM. You look at them, and fundamentally, they're all kind of the same. Having said that, every chip ends up being good at something, so ARM will end up being good at something. And maybe the fact that it is not Intel will be sufficient differentiation to make it move forward. And then finally, is it an app or is it a fabric? The reason we say that is because when your application is so modular, the way you govern the application and the way those modules interact, the way you do dependence management, and the way you do evolution and change management becomes a very difficult thing. So there's a standards body called OSGI. And OSGI came out of the Java world, but it enforces good behavior for modularity. So my recommendation, go join it. Just look up osgi.org, the OSGI Alliance. It is good stuff. It is the way to go. And that's really the end of the talk. Do I have time? This next one has nothing to do with technology, and you could argue some of the other ones didn't either. But this next one is because we said accelerated change, and I just, this is kind of what I use with some of my friends. So I'm going to go through it anyway because Sydney says I've got 5 minutes. When change happens, it's either an undesirable change or a desirable change. It's either expected or it's unexpected. So if it is undesirable and unexpected, life is awful. If it is expected and desirable, life is great. Change is best when it is your own idea. Change is worst when it is imposed on you. Now, we talked about this whole information age and the accelerated change and how, as human beings, we're not really quite biologically designed to manage it like that and do kind of, real-time renormalization and recalibration. So what do you want to do? When change happens that is undesirable and unexpected, you have to reinvent. You have to reinvent. And reinvent means what? It means when things change, they're not the same anymore. You have to reinvent. And when you reinvent, if it's undesirable and expected, you recalibrate. If it is desirable and unexpected, you celebrate. And when it's expected and it's desirable, you appreciate it and you count your lucky stars. So with that, I leave you to the good hands of information age, and I thank you for your attention. Please.
Yeah, I missed your part. You said Azure will grow faster than AWS.
That is our prediction.
Your prediction?
Yes.
How about Google Cloud?
So when it comes to cloud providers, we think that the leaders are clearly AWS and Azure, followed by Google and SoftLayer from IBM, followed by Oracle, which cannot be discounted. Oracle has a lot of the advantages that Microsoft has. They've got, on the B2B side, more than B2C side. But they are able to get all of those applications and bring them to their cloud, just like Microsoft has done. So we are far from writing them off. Even though they found their religion a little bit later than others, they are very, very strong. So we think like that. We also think that most of the people in the cloud world, there will come a time when they realize that these big guys are your supplier. They're not your competition. Right? So cycle computing is an example of that. They essentially OEM Amazon. They add value. They're not trying to build their own cloud because they don't have to. Right? So this is a really mental recalibration where you realize all these big cloud guys are your supplier, not your competition.
Thank you for such a great talk. I have a question about what you said about...
Stop there now. Such a great talk.
It was awesome. So we're in the information age, and I was thinking about Oculus Connect 3, where the chief scientist of Oculus talked about entering the experience age and the transformation from the information to the experience age from a user human-computer interaction design sort of perspective. But with that being said, I was wondering your thoughts in terms of predictions and projections. So with NVIDIA GPUs, computer vision, self-driving cars, given the fact that Snapchat just filed for an IPO and that they've bought about $2 billion in cloud ML space from Google, I'm wondering what your thoughts are in the transformation of how we're going to start architecting for what's to come. I'm working in the augmented reality and AI space, and it's still very early.
Absolutely.
But I mean, I anticipate everything's going to be in HPC, and people think I'm crazy. They're like, you haven't reached product market fit yet for your startup, but why are you talking about HPC? And I'm like, because everything's here. And so I'm wondering what your thoughts are when a lot of things start to merge. If Tesla's having a lot of stuff in AR, and people are quitting Apple to go work there. Like, I'm just very curious when we think about computer vision and image processing in the cloud. So.
Right. So I had an article in HPC Wire about AI and autonomy. Carnegie Mellon got funded to the tune of something like $10 million or something just about 6 months ago or so to look at the ethics of AI and automation. Automation, when you're automating your brain, essentially, the decision, it becomes fraught with ethical challenges. And ethical challenges go hand in hand with legal challenges. So our view is that autonomy is a fantasy. Autonomy only works in a highly well-defined scope. And to the extent that that scope is defined rigorously, it can work. When that scope is not defined rigorously, and sometimes we don't know until you put it out there, then it's going to cause problems. So will we have driverless cars? We sure will. Will they occasionally get in trouble? They probably will, right? Because the assumptions are different, the use cases are different. On balance, they may end up being better than the human driver anyway. So that really becomes the factor. Now, I think our willingness to forgive a machine compared to our willingness to forgive a human is very different, right? We kind of go nuts when a machine makes a mistake. With a human, depending on the human, you may still go nuts, but usually we're a little bit more forgiving. We're just human at the end, right? Machine, no, they cannot waver. So I think that's something to have in mind. On virtual reality and augmented reality, we didn't cover that, you're right. We put it all really under the AI. But that compared to now, what I think will make a big difference for that is 5G networking. So Orange and Ericsson demonstrated in France, like a couple of weeks ago, I want to say, a 5G network that is just kind of being tested. And it is like way faster. They were, I think, getting 10 to 12 megabytes a second out of this. Compare that with your LTE. So that is really suddenly going to open that up in a big way, assuming that the prices are such. But one of the reasons people say Facebook is in virtual reality is that there comes a time when you just put it on the glass and then, you can watch a movie together. You can roam around the protein and kind of point to it. I mean, kind of that movie Disclosure, remember? When you would just kind of surf inside the database. I think we are kind of a bit ways off from that. But I do think for specific use cases, like in education, like in emergency medicine, those, I think, are very valid. That's about it? All right. Well, thank you very much. We can now come back to reality and talk about real things. So thank you.